So yesterday we took notes on roots. You have that out because that's going to help you with this today. We have, remember I talked about vocabulary? And you're going to need to know vocabulary. Let's see if on this iPad this person has, yes, perfect, just like you were supposed to. Remember the list of websites you were supposed to put on your iPad? Yeah. It's here, Mrs. Belden. It'll be beldenmath.weebly. At the top, it's hard to see right now, but at the top you'll see a bunch of different tabs. HA is high ability, okay? Gen Ed is our class right now. We're going to click, and it says vocabulary. We're going to click on it. And if I look down here, it says Indiana Lessons, Volume 1. That's what we're at. When those pages say IN, they're Indiana Lessons. If I'm going to click on the Quizlet, it's going to pull up my Quizlet, Indiana Lessons, Course 2, Math 1. So I'm just going to, all the terms are down here, so I might want to read through all those terms first. Or I can do it by doing a flashcard and keep going, right? You have all different ways to do this. I suggest you study these flashcards because there might be a quiz before we take the next chapter test or our chapter test. Okay, so that's how you find it. You go to that website and click on vocabulary. Because in those vocabularies, this word square root. And we talked about this yesterday. A square root of a number is one of its two equal factors. Numbers such as 1, 4, 9, 16, and 25 are called perfect squares because they are squares of integers. So we have the word square root. I think this word means. What do we think this word means? Let me stop this for a second, and you're going to have to write on here too. If I have, let's just go with 5 squared. What does 5 squared equal? Just tell me the answer.
25.
Okay, 25. If I need to find the square root of something, I'm going to say the square root of 25 is what? 5. We just did the opposite. So square root is the opposite of squaring. So how does this word fit with the other words and concepts I know? Well, what is this?
Equal.
It's squaring. And what do we call that? There's a special name for that number that's up there in the top right hand corner. It could be any number. It could be any number up here. Yes, it starts with an E. Exponent. So when we have square roots, we have exponents. This word square root, is there a word in here that I know already?
Square.
Square. And then on the bottom right, it says, what makes this an important word for me to know? And that's good. Then we're going to go back up to this. If I have 5 squared equals 25, the square root of 25 equals 5, we said it's the opposite, right? If you do the opposite of something, you undo it. Okay? It's like if I add 5 and then subtract 5, I do the opposite, right? I'm undoing my adding. So this is, you are undoing squaring a number. And I'm using the number sign. I'm just going to use the number sign. But now they're asking us the relationship. What is the relationship between squaring a number and finding the square root. I'm gonna underline the word relationship. I'm gonna underline the word squaring and square root. Yes,
I know the answer to the question.
okay?
Squaring a number is multiplying it by itself, and then the square root is square.
Finding the perfect square. But the relationship between squaring a number and the square root, we're gonna use the mathematical term. It's the inverse operations. Inverse operations. So then if we have a real world link, it says the square base of the Great Pyramid of Giza covers almost 562,500 square feet. How could you determine the length of each side of the base? Here is our base, because our pyramid would look like that, right? So let's just focus on the base. The base is a square, right? To find the area is always length times width. If it's a square, these numbers have to be the same. So to find the length of one side, I would have to find the square root of 562,500. Then I could find the length. That would equal the length. I was sorting. You can't see this?
I can now.
Then move there. I'm not asking you to find that. I don't even know the answer to that. But if I wanted to find it, I'm going to use a calculator. I'm going to use the square root of that number. Turn the page in your book. Talking about square roots again. Words. A square root of a number is one of its two equal factors. If 5 squared equals y, then x is a square root of y. For an example, 5 squared equals 25, so 5 is a square root of 25. We're going to do some writing on this so you understand what it's like to look like it with the variables. So I'm going to rewrite this again. And you are going to do the same thing. 5 squared equals 25, so the square root of 25 is 5. And you'll write that with the variables. X squared equals y, so the square root of y equals x. Every positive number has both a positive and negative square root. We talked about this yesterday. In most real-world situations, only the positive or principal square root is considered. A radical sign, we learned that yesterday. It's not called a division sign, it's a radical sign. Is used to indicate the principal square root. If n squared equals a, then n equals the positive or negative square root of a. I'll give you another example with the number, because sometimes it's easier to remember with a number. I'm going to say 6 squared equals, what does 6 squared equal? 36. Then the square root of 36 equals 6. Okay? And you're going to say that's the positive or negative, because this could be positive or negative. Again, when we get out of the Indiana lessons and into the pages where it like starts at page 1, we have a tutor button that would be purple. if you're at home, you can hit that tutor button and it's gonna help you solve these problems. There's gonna be a teacher teaching you step by step. You won't see a teacher's face though. Sorry guys. So we're gonna find the square root of 64 in our book. The square root of 64 is 8, because 8 squared is 64. I want you to write that. Or I want you to underline it because they have it written there for you. You need to remember it's 8 squared. Number 2 is a bit tricky because now I'm throwing in a decimal. I first want you to think of it without a decimal. So in this space, you can probably write in this space, I want you to write the square root of 121 equals. You need to look at your paper from the notes yesterday if you don't know what this is, because this is a perfect square that needs to be memorized. Antonio?
11.
It's 11. Okay? So if I come over here and I do 11 times 11, and you're doing all of this work, you're even showing 11 times 11. 1 times 1 is 1, 1 times 1 is 1, add a 0, 1 times 1 is 1, 1 times 1 is 1, and I get 121. There's a reason why I'm having you put this in here. I know you know how to multiply. It's because we added a decimal. We added a decimal in there. And if we added a decimal in there, in my answer, my decimal would be here. Right? Because that's what I really want.
Yeah.
So if I go up here, how many places are my decimals?
2.
2. So I go up here and I have to have the same number. So I have to think, where can I place my decimal to have the same number but have 2 place values at the end? Well, you're going to put it right here. Is it 1 and 1/10 the same as 1 and 1/10? And I just moved it 1, 2, so I start on the right and I go 1, 2. So that's how you get your final answer. So even though they have all this information that you can read, I want you to add this because of the decimal. Here to find the square root, the negative sign is on the outside, which is fine. If the negative sign is on the outside, you keep it in your answer. Then I just need to find what's the square root of 25? 5. What's the square root of 36?
6.
But then you put that negative sign in front of your answer. Number 4 is asking for the square root of 16. What times itself gives me 16? 4. If I do 4 times 4, I get 16. Is 16 the same as negative 16? No. But didn't we say we could do negative numbers? So let's try a negative 4 times a negative 4. A negative times a negative is still a positive. So do I get the same answer? The only way you can get a negative if I do a negative number times a positive number to get a negative 16. But would those be the same numbers? No, they're not the same numbers. So that doesn't work. If the negative sign is inside the radical, there is no answer. There's no real solution. You can't have one. So let's take a look at our got it problems. Letter A, the square root of 9/16. So what's the square root of 9? What's the square root of 16?
4.
So your answer is just 3/4. The square root of 81 hundredths.
9.
Think without the decimal first.
9.
9, that's pretty easy. Now, at the end, when I take 9 times 9, I need 2 decimal places. And this has to be the same number. So I can't put 2 decimal places in one and not the other. So how many decimal places do we put it in? 1. Over 1, so it's 0.9. Over 1, 0.9. Because then when I finish it, I go 1, 2 decimal places. Off to the right, 1, 2 decimal places. So your answer is 0.9. And then we need to add its plus or positive or negative. It can be both. I think those are going to be the ones that are tricky for you guys. The square root of 49.
7.
Okay, and I'm going to bring, it's 7, but the negative's outside the radical, so you better bring it with it.
Oh, -7.
So it's -7. It cannot be +7. For D, the negative is inside the radical. Can't do it. So you say, no real answer. Don't say I can't do it. You just need to say there's no real answer. So let's go up to example 5. Solve t squared equals 169. So what you're trying to say is what squared gives me 169? You guys probably don't know it. That's why you have your notes next to you. Look at your notes.
13.
What? 13 or 14? 13. Because 13 times 13 equals 169. And we're saying that the square root of 169 is 13. It's positive and negative. You have to have both. So looking at the got it problems, 289 equals a squared. So this is saying what squared gives me 289. So you're also saying the square root, I want you to write this down, of 289 is, I would look at my notes, 17. F, we got another hard one because they added a decimal. Don't think that decimal's there. Pretend that it is not there at all. So what would be the square root of 9?
3.
3, okay? We got that. How many decimal places do I put in the number 3?
2.
Can't put it, watch if I put in 2. Look at this. If I do this, times, just watch. You said put in 2 decimal places.
No, put in 1.
Because if I put in 1, 2, 1, 2, that's 1, 2, 3, 4. So my final answer would be 1, 2, 3, 4.
Oh, no, that's.
Is that the same answer?
Only one.
No,
Yeah.
only 1. Because you would add it twice. Because you'd have a decimal in one of them and a decimal in another. So it'd be 0.3 times 0.3. 3 times 3 is 9. 3 times 0 is 0. And then I count 1, 2. Start on the right. 1, 2. You guys understand how we are getting that? So M equals 0.3. So for G, you're figuring out the square root of both of those numbers. Put in the radical sign. So the square root of 4 is 2. The square root of 25 is 5. So Y equals 2 fifths, because 2 fifths times 2 fifths is 4/25. All right, looking at the next page. If we couldn't get any harder with all of those squares and decimals, now we're going to say we have stuff that is cubed. think of a cube. If I have a cube, I'm gonna draw one here. And I wanna find the volume of this cube. Volume is length times width times height. If it's a cube, they're all the same length. We always say the answer, let's say it's inches, it would be inches cubed. The reason why we're saying it's cubed is because there are 3 numbers. So cube root of a number is one of its 3 equal factors. If x cubed equals y, then x is the cube root of y. We're going to write x cubed equals y, so the cubed root, and you write it like this. You put a 3 in there.
Is that a 4 or a
Y.
Y?
Sorry, y. So the cubed root of y is x. Numbers such as 8, 27, and 64 are perfect cubes because they're the cubes of integers. 8 is 2 times 2 times 2 is 2 cubed. 3 times 3 times 3 is 3 cubed. 4 times 4 times 4 is 4 cubed. You're going to want to make a list of the next one. So if these are 2, 3, 4, what's my next number?
5.
5, so let's do that. Well, actually, that one is there for us, right down here in this example.
Good afternoon,
And
pardon
then
the
we'll do
interruption. I just wanted
6
to,
times
again,
6
wish the 6th
times
and 7th
6.
grade football players good luck tonight. And just a reminder to our 6th graders, I've been walking through the 6th grade hall and I've kind of noticed there's things in the hallway, some just various items. So if you can, guys, and you'll get better at this, I know, but try to make sure that you put all your stuff into your locker. Don't leave it laying out in the hallway if you could. We would appreciate it, and try to keep it picked up too. Okay, that's all I have. Tomorrow is Friday. I will see you all tomorrow.
We are not going to get any further in this lesson, but you have to submit something today. So you guys are going to go back to page 10, where you wrote all that information down. You're going to take a picture of page 10, and you're going to go to Canvas. Thursday, August 27th, lesson. Take a picture of this page 10 and submit it, and you'll have that red button that says submit.
Thank you.
Thank you.